Okay, problem 6. We have these three boxes. We're given the masses of all of them. Given MA, MB, MC, and we know that this is all frictionless. Actually, they didn't tell us, but you can't solve the problem without knowing the friction. And since they don't tell you what it is, you can sort of assume it's frictionless. So not great, I know, but there you go. The pulley is also frictionless. So the first thing we want to find is when this thing is released from rest, what is the tension in the cord that connects boxes B and C? So, here's, tell you what, I'm just going to draw free body diagrams for all these things. Free body diagram for box A. It's sitting there, so what's it going to have? It's going to have tension in the cable, no friction. It's going to have weight, and it's going to have a normal force. Okay, so tell you what, let's define, while we're here, let's define our acceleration A going that way. So positive A goes that way, and then positive A goes down that way. So this means when block A goes to the right, blocks B and C go down. And if we define A down for B and C, positive A down for B and C, then we can use the same A. Okay, so for block A, sum of forces in the x direction. Oops, let's do x and y, like that. Sum of forces in the x direction equals m of A times A, which is acceleration to the right, right? So tension equals ma times A. Well, that's easy enough, right? Okay, so FBD for block B, and there's, oh, that's MA, by the way. Yeah, but anyway, it doesn't matter. Okay, block B, you've got the tension, and so actually I'm going to call this, okay, I'm sorry, I hate to keep going back and changing this on you, but I'm going to call this, actually, no, I'm going to call it, we're going to call this cable 1, and this, or cable 1, and then 2 is the one in between there. So T1, and then, so that's the tension in this cable. T2 is the tension in this little one here, which is actually what we want to find. T1, okay, so T1 pulling up, we have T2 pulling down, and we also have, I'm going to make a really big dot here, mass of 2 times G pulling down. I'm sorry, it's the mass of B. Good Lord, I can't do anything right these days. All right, so sum of forces in the y direction here is going to equal, so, oh, why the hell did I do x and y like that? That's completely wrong. I'm so sorry. Okay, so let's, y, there we go, x. Okay, so x, y, and over here we have x and y. So sum of forces in the y direction, we've got, this is going to equal, now our acceleration here is down, so we actually have to do equals mb times negative a. So that's why I'm writing negative mba. Okay, T1 is up, minus T2, minus mass of B times G, equals negative mass of B times A. Okay, so let's see. Tell you what, let's hold on to that for a moment. So I'm going to call this our equation A. I'm going to call this equation B, and then we're going to do, let's do the free body diagram for block C, and there's C. So you do this, you have tension in cable 2 pulling up, and you have the mass of C times G pulling down. Okay, so sum of forces in the y direction is T2 minus mass of C times G, and that's going to equal MA for block C, which is MC, and then block C is accelerating, positive acceleration for y would be a negative A. So we need to use, again, we need to use negative MC times A. This is horrible. All right, so what we have is T2 minus MCG equals MC times A. Okay, so now we've done this. Let's do T2. We want to solve for T2, right? So let's do T2 equals MC times, is that right? Oh, sorry, this should be negative here. Yeah, equals negative MCA. So this should be MC times G minus A. Where can we find A? Well, let's see. We can take these two equations, right? So here's T1 is MAA. Here's T1, T2, blah, blah. So let's take these two and put them together. And we can combine these two. This T1 here can go into T1 there. And we can put these together and do MA times A minus T2 minus MB times G equals negative MB times A. Oh boy. So let's see. Let's solve for A. Let's see. So what's the best way to do this? So I think we can do MA times A plus plus MB times A equals T2 plus MB times G times G. Times G. There we go. All right. So moving this down a bit to get a little more space. Then this lets us solve. Oh boy. So A equals T2 plus MB times G over, boy, I hope this is right, plus, over MA plus MB. And then finally, wow, this is going to be ugly. So we take this A here and we substitute this in. And so the final equation this is going to give us, well, let's see the relationship that we get here. So let's come all the way over here and do, you know what, actually, let's make this slightly easier by taking this equation and solving this out for A. So actually up here, well, you can't see that part, can you? Okay, so I'm going to take this equation here, move this down there, and do T2 over MC equals G minus A, which means that A equals G minus T2 over MC. So then we have this A and this A. And we can set them both equal. So that and that, we can set them both equal. And then we get T2 plus MB times G over MA plus MB. That equals A, and this equals A. So equals G minus T2 over MC. Holy moly, that's annoying. Okay, so now we got to collect our T2s. Oh boy. Okay, so let's go to black, and we're going to multiply this side, top and bottom, by MC over MC and then we're going to multiply this side, top and bottom, by MA plus MB over MA plus MB. Wow. Ugly. If you got numbers, it'd be a great time to plug them in. But I'm just going to go the total masochist route and see if you can see how to solve this now. You might want to just end this video and sort of be merciful to yourself. So T2 plus MB times G, and that's actually MC times T2 plus MBG times MC over MA plus MB times MC equals G minus T2MA plus T2MB over MA plus MB times MC. And my handwriting is getting sloppy because I am really getting annoyed, but this should actually come out not too terribly bad. So we're going to take this whole thing here, which is subtracted, and we're going to move over to the other side where we can add it. And then actually what we'll get is T2 times MA plus MB plus MC, okay, plus MB MCG over all this MA plus MB times MC equals G. Nasty, nasty, nasty. So we do that, and then, blah. Let's see. Oh, that's all right. So actually, we can cross multiply all this. Oh, actually, this will come out better than I thought. So T2 times MA plus MB plus MC over, oh, wait a minute, no, okay, plus MB MC times G, multiply this over, equals, and this is going to be MA MC G plus MB MC G. Okay, so the payoff for all this pain is that this and this cancel. So now we can take this and say, and this is where our pain should hopefully end, T equals G MA/MC over MA plus MB plus MC. And that's actually, that was T2 actually, I lost. Yeah, anyway. So, wow. Hope that's right. No idea, but if not, you know what, I don't think we're doing any more of this. Okay, and then what was the other question? How far does box A move in the first 250.250 seconds? Assuming he doesn't hit the pulley. Well, we had acceleration, so let's see. The acceleration, what's a good thing for acceleration? Well, a good place to find acceleration would be here, since we know what this is. So I can say right here. So unfortunately, I don't have any room left because I've used up all of my page. I can't scroll down any further. But we have acceleration equals G minus T2 over MC. Oh, and of course this T2 here, no problem, right? So acceleration equals G minus GMA over MA plus MB plus MC. You know, at this point, hopefully you're using numbers, right? And that's the acceleration of block A. So you apply D equals, or delta X equals 1/2 AT squared, because it's starting from rest. They gave you T, and then you find it out. But I'm not going to do that. You know, you can figure that out. You can take this A, plug it in, plug in the T they gave you, and go nuts. Anyway, there you go.